Hello and welcome. Today we're looking at electrophilic aromatic substitution reactions, where we're looking at two types of reactions, Friedel-Crafts Alkylation reaction and Friedel-Crafts Acylation reactions. And this presentation is brought to you by Science Visualized. Number 1. Friedel-Crafts Alkylation reaction. In this reaction, you need an alkyl halide and aluminum trichloride. And when you mix those two together, you end up generating a carbocation intermediate. That's carbon with a positive charge. Carbocations intermediate can undergo rearrangement, where we expect the allylic carbocation to be the most stable, which is more stable than a tertiary carbocation, which is more stable than a secondary carbocation, which is much more stable than primary carbocation, and that's much more stable than methyl carbocation. In this case, we form a secondary carbocation because you have 1 and 2 alkyl groups, so that means this carbocation is secondary. But if that was to undergo rearrangement, you end up moving that positive charge to this carbon or to this other carbon, and that will give you primary carbocation. But we see that primary is less stable than secondary, and therefore the secondary carbocation will be the major product. So in other words, you just proceed and add this as an electrophile, and therefore you end up replacing the hydrogen with the electrophile, and that becomes a product. So the end result is that you've added the alkyl group to the aromatic compound. The second electrophilic aromatic substitution reaction is called Friedel-Crafts Acylation reaction. And in this reaction, we use acyl halide or acid halide. So you have the halogen there, where the halogen can be chlorine, fluorine, iodine, or bromine. And you use aluminum trichloride catalyst. When you mix those two together, you generate what's called an acylium ion, and that acylium ion is stabilized by resonance. So you draw that resonance structure, showing that the positive charge on the carbon can be delocalized. So by moving these two electrons, here you get a triple bond like that, and now the positive charge moves to the oxygen because now it has a formal positive charge. You still have the other two electrons on oxygen. So both of these are acylium ion, where the carbon position is actually electrophilic, so it will accept nucleophiles. And you end up adding the acylium ion to the aromatic compound. So basically you substitute the hydrogen with the acylium group, and you end up with that as a product for Friedel-Crafts acylation. The advantage of this is that there is no rearrangement, and the reason for that is because the acylium ion is stabilized by resonance. Thank you very much. Please subscribe and support the channel by commenting and liking the videos. Bye.